So let's talk on the one more algorithm known as a selection sort. So we're going to talk about this uh, selection sort as algorithms. So selection sort is also a comparison based algorithm. That means here again, just like in the last session, we talked about the bubble sort algorithms, where they are comparing compare based comparison based algorithms. Similarly, here selection sort is also compared based algorithm. That means we are going to comparing one element to the other elements and deciding which is less than or greater than or equal to. According to the comparisons, we decide our input list can be sorted or not sorted. So let's first we talk about the approach, how this selection sort algorithm works, and next part we discuss how we can approach to implement in a Python. Okay, so this algorithm is little bit minor changes with the selection sort, and here say this divide the input list in the two parts. So what this algorithm say? They are say whatever the input list we are receiving, objective is that we are going to divide the list. But here division with not the division which you think. This is the division which other one approach. What the approach? They are just assume the list we receive, that is the one list that is an unsorted list, right? This is unsorted list, and we are going to make new list that is a sorted list. Okay, objective is that. Okay, so here to start the part of at the beginning and unsorted part of the end. What do you mean by here? Here means whatever the elements. So let's keep first elements just divide with the first element. So the list is divided into the first element. Only one side only one element, another side the all the elements. Okay, that means we consider the only one element. If we have a list have only one element, that's 7. This is the sorted element. So this part of the list known as a sorted list, and this part of the list is unsorted. So this approach say let's we have a logically understand the first element is the sorted and the rest all are the unsorted. So what is the next approach? We have to from here find all the smallest and move to the this part. This is your unsorted part and sorted part. So selection sort say let's select one element. This is the look like a sorted, and rest of the elements and select who is the next. Choose this the smallest one again and put in the shortest list. If we have only one element here, and I move the another element, I know okay, this is if less than or greater than, then we have to we have to put it. But now this becomes a sorted list. So here say it's repeatedly selected the smallest or largest element depend upon the that you are decided you are going to make our list in ascending order or the descending order. Accordingly, you have to select which is the smallest one. Okay, and an unsorted part and move it to the sorted part. So what the algorithm here say? So whatever we have, we have a input list. Okay, so we assume this is the my first element. This is the first element. Assuming this is the sorted, and now let's from here the other part in this part only. I am going to find the what is the smallest element one. Whatever the smallest elements compared to this. Okay, so let's say here maybe some number 8, maybe 2, maybe 6. Right now, if this is that we select the first position here and check rest. Assume this is the unsorted list. So you can say compare with this. This is a comparison based algorithm compared to this. It is the less than, yes, it is the this then. If you compare to this, it is the less than, yes, it is then we have to sweep, so change the value. This is the now become a 2, now become a 8, now become a 7, now become a 6. So now this is the you swap the number. Again, this is the first place we get. Again, compared to the rest, 6 less than that. So in the first pass, you notice whatever the smallest element, we can get the first place. Then similarly, we have to move. This is the first time, this is the sorted part. Now move the sorted part from here. That means we have moved on the select the next element. Next element here 8, 8. Then we have select 8 to the 7. Yes, 8 is the greater than. Then we have say 2. This is the 7. Now we, excuse me. So you swap again. Now this place, second place become a 7, 7. You can again compare to the 6. Compare to the 6. Now again, the smallest. Then again swap 2, 6, 8, and 7. So notice first two elements are the sorted and rest is the unsorted list. So this is the logical division of sorted and unsorted. Again you choose the first one. Again compare to this. Oh, again that means 2, 6, 7, and 8. In this way you get the sorted list. So this is the approach. The approach is very simple, and let's understand with the example. So let us understand with the example. This is the, let's assume this is the one, our sorted, this is the, let's sort this is the in ascending order. First you have to decide you are going to sort your list in ascending order or descending order. By default, whenever say sort, we assume you are going to make a sorting in ascending order, like 1, 2, 3, 4, 5. This is the natural order. Sometimes you want to descending, then you have to specify descending. Okay, so again steps one, first find first let's assume for this place position 1, I want to find the smallest element between the rest of the array. You can take 27 as a first element and compare to the each and find what are the between these first, what are the smallest element. So let's compare the current list is, you can find the 10th is the minimum. So the 10th become your first place and rest become a this. So just say comparing here, comparing one by one, comparing with this, comparing with this, comparing with this, comparing with this. In this way you are comparing. Finally, first place, single, find again the first, already this is sorted, then again find the next minimum. So you already find the next element. What are the, this is the unsorted part and this is the sorted part 10. So here what is the smallest? Smallest is the 13. So you can say this is our sorted part and this is the still unsorted part. The fourth step, again go, what are the unsorted part? This, find the minimum. Minimum is the 14. So this is our sorted part and this is again unsorted part. This is the unsorted part. Again find the minimum. What is the minimum? Minimum is the 29. So you can swap them and you can say finally you get this the complete sorted. So as mentioned, selection sort means you are selecting the position 1 and what are the minimum to the anyone we can replace them. So in sort you can say, as the name mentions, selection sort, nothing, whatever the input list we receive, just select the jury position and find what are the minimum between the completely here. Okay, whatever the minimum, just place this is the minimum. Again next time select the one position, what are the minimum remaining, and just place this the minimum. Again select the third position and find what are the minimum, just put here the this is the minimum part. Again select the position, what are the minimum, and this way you can just select one position and find the rest, what is the smallest one, put the first, then second, then second. You notice this is the different approach to solve. Look like a in a bubble chart, what we did bubble chart say we are going to the comparing each and every element with the adjacent. First compare with the this, then compare with the this compare with the this compare with the this. And if any required swapping you can do. But in case of your selection sort, you choose the position 1. And position 1 compared to the this, if minimum then swap. Again compared to the this, if minimum to change. Compared to the this, if minimum to change. If compared to this. Okay. In this way, selection sort say first come take one and find the minimum and place here. Similarly, you can go for the next. Similarly, go for the. But this is the logically different approach, but the both are the make your element is the sort. So let's look how to write the code for the same. Let's explain, then I can write the code. So simply you define one selection sort methods that take your input as array, and first you calculate the length, and again just the same algorithm. We if a number is less than, then you can find the minimum here and swap them, and whatever the minimum position you can swapping here at. So let's write the code so that you can explain what here do. First you are like taking a your first, let's explain, then we write the code. Okay, your this is the let's array, this is the zero position, 1 2 3, let's 4. Okay, this is the your element. Okay, so here say let's this is your min index. Let's assume this is your first place is the minimum element, and again you are going to run the loop from here to here till and figure out what is the minimum compared to this number, this place. Okay, so this is the value and find which is the minimum. This is the, yeah, this value, whatever this one value, j is equal to start from the, notice here plus 1, start from 1 and check this value is less than, then change the minimum is this or this or this. Finally figure out what is the minimum position value, whatever the minimum index, that index finally you swap with this index to the specific value whatever. So finally once this loop complete and find, hey, what is the minimum. So whatever the minimum index you find, you can just swap the first element with the minimum index, and the minimum index the remaining value count. So this is the way. First you identify this is the position 0 and making a loop and finding the minimum one. Okay, whatever the minimum index you found, and finally this is the minimum, this is the minimum. You can swap this with this one. The swapping happen in one pass, only one. But in the case of notice in the bubble chart, every compare you may be swap, every may be swap, every may be swap, every. Here notice that the inner for loop we are not making any swapping, swapping only at the position level. So let's write the code so that you can. Okay. So let's just define one selection sort. Okay, and you take a array as an input. Okay, so first you have to take the length of your input length. Okay, and you have to just make a loop to 1 to your number of length, whatever that, and then you can say what is the minimum index. Okay, what is the min index. Let's min index 1 2. Then you again start loop from the next j plus 1 more than 1, and then figure out something what is the minimum index, and whatever the minimum index you can change the minimum index this. And once this loop comes, okay, once this loop come, you can okay come out the loop, this index find out the minimum, and once this done you can say, hey, this is the a of I. Now the whatever the first position data, you whatever the minimum index you can change, at the minimum index you can change, fine. And just even you want to just print element, just check what is the sorted. Okay, just close the loop Just close the loop here, and let's call the and test it. Let's print input, your input array, and this is the output, right? So what you did, let's do one by one. First calculate data, right, and check it's working. So now this is the first time in the whenever your input first pass, let's say here write the here write comma uh, is pass steps pass comma I a comma just understand. Yeah. Okay. So pass one, first position, you have a find the what is the minimum here? 10. So you can step the 10 here. Second time, one position. What is the minimum here? 3. So what here we did, let's look. Hmm. Let me just look. Okay. So here let's make a pen. So here your this is your initial, this is your initial data where you can mention the 29, then you can 10, then 14, then 37, then 30. This is your first position data, 1, 2, 3, 4, right? So let's start with the first. Let's assume we have create one variable minimum index. Okay, this is the minimum index. Okay, main index. I start with the first position I, that means 0. You started with the minimum index 0. Okay, and here you can make a loop from I plus 1. That means this is your I start from 0. This is 0. So 0 plus 1, that means from here you are going to make a loop and find out who who is the smallest element so that we can swap them. The first check j plus 1, that means this is your I, this I start with a 0, right? This is the I start with a 0, min index 0, and again you start j is equal to j plus 1, j is equal to j plus 1, that means the I plus 1, that means it become a 1. So you can say a of 1, a of 1, this 10 is less than, you can say 10, this 10 is less than a of min, min means 0. So kya 0, that means these two are 0 position, they are less, yes, less. Then you can say change the min index j, that means ki this position j position is the your min index. Now this is not min index, min index is equal to 1, the minimum is equal to 1. Again you make a loop, again j equal to become a 2, again 2, here 14, is 14 less than a of 1, that means here is less than, no. Again a become a 33, 37 become a min index, that means 1, they no, here no. Here in finally whenever you run the loop, finally you find out the min index is the j. So once this loop come, finally you find out the j is position 1, position 1 is the smallest element, position 1 is the smallest element, that means we have to swap position 1 with a 0. Here notice a of 0, mean first position, here you place the min index 1, this value you are swapping, this value here you are swapping 10 and rest the number here. Okay, here 29. So notice here you find here first index, this is the input index, and what is the smallest index, this is the 0 position, and you find the minimalist is the 10, you can 10 is the first. Now this is the sorted element star. This all are the again unsorted. Similarly, you can go for again for the one this position. You have started now this position, one position. Figure out who is the smallest, and notice this is the itself is smallest. This is the smallest. That means there is a no change required. Okay, same place. And here again, second, he disclose 14. 14 is find out the smallest, 14 is smallest. Then again, this is sorted. Next place, third number. Third number. Swapping required? Yes, swapping required. Swapping. Finally, you get the all the swapping. So this is the way you can find the smallest element in each pass in pass and make your final list is a sorted list. So the algorithm is very simple, as name mentioned, selection sort. What you simply doing, just pick up the one position one, and figure out in whole unsorted list who is the smallest one. Who is the smallest one, and put the smallest value at this first place. And similarly, in the next page, you're going to select the now the first position data, and again this is the complete unsorted. Figure out who is the smallest, whatever the smallest, just swap with the this thing, second page. And similarly, go to the select third page, you go to the check the zero element sorted, one element sorted. Let's select the two elements, again find out between that who is the smallest one. Who is the smallest one, just swap it. So this become a sorted, this become a sorted, this become a sorted. In this space you can figure out, hey, this is sorted thing. That means the first place one and comparing to each one, finding who is the smallest and swap them. Again next steps, comparing and comparing to everyone, find the who is the smallest. Third place, comparing the who is the smallest and replace them. So this is the a way you can implement. This loops just say find out who is the smallest index. With the first, let's assume this is the minimum index first, and then compare anyone other than minimum, then note that. And once this loop say, hey, this is the minimum index, then this value, whatever the index you selected, you swap with the minimum index value. And again, minimum index value, the whatever the value this is. So this is the way you can provide the implementation of the selection sort. So let us suggest, you can just for your references, you can just comment out, and if you run here, you notice this is the input. This is, so let's you want to not the ascending order, you want to descending order. So here we have to make some flag, or you can say again similarly kind of code you written, maybe like uh, let's uh, let's maybe descending. Okay? Descending order. Okay? So what here do, nothing you can change the code, just here change the, instead of min, let's change the syntax here, greater. Now this whole code, now instead of min you can say max index. Let's assume this is the max index. Okay, variable name just for logical okay, this is the max index. So in this way, all the programs, if only this condition, instead of less than, you can find out the greater than. And let's this is the ascending ASC. Let's descending descending. So as notice, this is your ascending, and this is a descending. In this way, you can notice our code is key in the same, no change. Only this condition, if you are finding the smallest one, that become ascending. If you find this maximum biggest one, that become a descending. So only this condition, if you change, you can get the change, ascending order, descending order, or whatever you want. Okay, sometimes maybe you can write two methods, or you can let's check some parameter, descending true or false something. Let's boolean. If something boolean, then you can less than or you can guess. You can write some code, whatever the parameter. The generally good option, instead of giving the overloaded method, let's give the different name, so that if someone going to call your API, they go, oh, this selection sort for the descending order, this selection sort for the ascending order. You can, whenever you are defining any method, your method name should be as clear, so that anyone can going to call your methods, they are not confused. So all the whatever the code you written here, all the codes are summarized by your method name. So your method name should be clear and be purposeful. What the code you written here, complete codes are used by with your method name. So whenever you are writing method name, don't worry if method name is going to some big, let them be, but give the very concise name, so that your complete business logics can convey. If you return some methods, method name is something unknown, no one going to call your method. Whenever, let's say I am going to check some library, okay, then you have to figure out what the logical name for this the method. Okay, so please be uh, take some time, think, be carefully what the method name would be. Okay, whenever you want ascending order, give the proper name. Whenever descending order, give the proper name. uh, the algorithm is the same, just your condition. In the, you are finding the minimum index, here we are finding the maximum index, and just same code work for the both. Algorithm is the same, whatever you want to just use it. Okay, so this is the codes which we discuss how we can write the selection sort. Okay, so just let's you write yourself. This is a very small algorithm. Then let just practice. Okay, yesterday we practiced about the bubble sort. Today we practice about the selection sort. So let's you write the code. Sorting is the same algorithm, but only little bit different approach. Here, bubble sort, you say we are going to compare to each other and swap required. Compare to each other, required. Swap required. Compare to each other, swap required. Compare to the swap required. Here, let's select the, this is the position 1, and find the smallest smallest number position. Let's say this is the smallest number position. Okay, how to find? Just compare with this, compare with this, compare with this, and compare with this. Whatever the smallest elements, if let's in whole, this is the smallest one, just you can make swap the one time. Here swiping maybe one or two times. Here always swiping only one time, because you are finding the minimum index, not the swiping each and every time. So just approach same, but both algorithms you can, both are you can implement for ascending order, yeah, descending order. Just change your if condition while the checking if less than or greater than. You just change the symbol less than to greater than to less than. Your complete algorithm change from ascending order to descending order. So let's practice this, and hope this explanation help something helpful for you. That's for today. Thank you.